We good?
Yeah. So this is obviously the Vault network. So just a very brief overview of vaults. So it's very related to that language in the network blog post that we've got. So we've got certain identities on this network. We have client, node, client, manager, node, manager, and network addressable element manager. This guy here is where a lot of the work actually gets done. So we don't really need to go over again. We can understand what a client is. It's somebody that's not in the routing table. So for our, when we're in the Vault library, we just consider client as a user. So a client node is basically an access node, like a web browser, if you like. That can read information off of this network. So if this is the Vault network, the basic thing that a client is a browser, and he can read the network as though it's just one great big huge data repository in whatever shape we want that data to be, whether it's web pages, bits of hard drive, bits of programs, anything. So any kind of data. Your client in general is something that can read from it. For us, if we just consider the network, let's do it like that. We'll just consider the network like this at the moment. So when the client's in this browser thing, the client manager doesn't matter because we don't manage browsers. We don't care if people are looking at the network. We don't need to do any management of them. The client manager is not required when you're just a browser of data on the network. In terms of being this user, your view of the network is get ABC, and that thing goes to the part of the network which controls ABC and returns the data to you. So great big network, you ask the part that's responsible for that piece of data and it comes back to you. So that's what you see. Just like a web browser is not aware of the internal workings of a web server, here a client in browser mode is not aware or cares about the internal workings of the MaidSafe network. And slightly different, the MaidSafe network has no ability to prevent this happening. So anybody at the moment can read any piece of data. They're not managed and the piece of data just comes back to them. So that's a kind of one of the fundamental things that the Vault network does. Where it gets tricky is when we want to mutate this whole thing, when we want to mutate the network. That's when it gets hard. And also, how does the network look after the data? So if we tried to explain the vaults several months ago, we'd have been looking at a 2 or 3 week presentation here and get through things like synchronizing and passing keys about and doing all sorts of stuff. But this has been simplified a lot now by the routing interface. So what the routing interface fundamentally will do is say, here's a message, and it'll tell you several things about that message. So it'll tell you the type of call, so get, put, post, and it'll tell you your authority, and it'll tell you from authority, and it'll have a data type identifier. So these are the kind of fundamental things that routing will give us in vaults. And that alone gives us a lot of power. So we can tell what this thing is that's getting passed up to us. And the message from the vault layer is valid 100%. We don't need to do any work here. We don't need to confirm, am I really this authority? Did it really come from there? Is it really that data type? That's all 100% valid as far as we are concerned. And it's routing's job to make sure that that is the case. So with that information coming to vaults, it gives us the ability to do certain things. So if we're a vault node, this thing here is going to say your authority. Now, so you could be client manager, node manager, or network addressable element manager. Now you might think, why do we keep calling this network addressable element manager and not data manager? Network addressable element manager is the group closest to the name of the data. So this message has got a name and content. We don't know what type it is. The content could be 3 or 4 things, 5 things, 2 things, 1 thing, but it's got a name. So the group closest to that name is your network addressable element manager. And what that decides to do with that piece of data is entirely up to us as programmers of the Vault network. So when we get this thing through here, then we use the sort of language of the network host and make decisions. So let's see someone was storing a piece of data. So it's a client, he's going to try and store a piece of data now. So he's going to try and mutate the network. He's going to try and mutate the network, so he's not doing a read. So he's going to, this is something that has to be managed. He's trying to mutate the actual network, not data that he owns on the network, but mutate the actual network. So the call that he would use there is put mutate. And when we say mutate here, what we mean is he's going to put something onto the network. He's going to actually put a piece of data onto the network. The network's going to grow in intelligence, if you like, with this store piece of data call. And in our vault, so once we get this message up from routing, our vault's going to analyze the message. So we're going to be told we are, in this store data thing, we are either a client manager. That's the first thing we're interested in, is our authority. We're a network addressable element manager, or node manager, or a node. So this store data comes in, and if we're a client manager, we ask ourselves the question, is user allowed to store? Put. So is the user allowed to put this piece of data? So we're saying here, if we are a client manager, is the user allowed to put the piece of data, i.e. is from authority a user? Right. Then we ask the question, does user have authority to store? So how do we know if the user's got authority to store? It just came out of the blue. We don't know them. So we can't answer that question. Does the user have authority to store? Because we don't know anything about the user. So what has to happen is these guys obviously have to know the users they're responsible for. So before someone can try and mutate data, we are saying they have to have an account. And that account, from the client manager perspective, needs to be able to answer this question. Is the user allowed to store this piece of data? So how do we understand if the user's allowed to store this piece of data? So his account has to show that he has this ability to put more data in the network. So for us, eventually what that will mean is he has purchased space via SafeCoin. Previously what it meant is he had a vault that had stored plenty of stuff on the network in this quid pro quo thing. But basically we need to know, has this guy purchased space and he's got any left? And does what he have left cover the size of the piece of data he's trying to store? So we get this thing as a client manager. It says you're a client manager, so we can say, oh, if I'm a client manager, it must have come from a client, and if it didn't come from a client, drop it. So if it's not from a client, drop it. We don't do anything with it. We're a client manager, we want spoken to with a put from a client. So we drop it. If it's actually from a client, we look in our accounts list to say, does that client have space left? And if he has got space left, then what we're doing is we're going to the next step. And the next step is basically we're going to send the data then to network addressable element manager. So network addressable element manager says, I'm not going to speak to a client. It's going to say our authority is obviously network addressable element manager. That's going to say the from authority should be client managers. And if the from authority is not client managers, drop it. So I'll put that over here, same as here. From is client manager. So if it's not from a client manager, drop it, because that's all we're speaking to just now. So network addressable element manager, what's he asking? What questions is he asking? Is already stored? Or does it need stored? So this is where he's looking at first. He just gets the message, says this from a client manager group. Routing should have confirmed that it is. And how routing does that is kind of irrelevant to us here. We don't care. So when you're in vaults, don't even put your head in that area. It's routing's job. So if it's from a client manager group, then we're really saying, is it already stored? If it's already stored, our job's done, we're finished. That's fine. Somebody tried to store a piece of data, the network already knows about that piece of data, it's complete. That's A-OK. However, if it still needs stored, then the network addressable element manager would basically return to routing, same as this guy did. So this guy said there is space left, pass the message on to network addressable element manager. Network addressable element manager checks if it's stored or if it needs stored. If it needs stored, it passes back to routing. Send this to node managers. A node manager group. And the node manager group.
Right now will be cut out, but it's below the camera level.
Oh, is it down there? Oh, let me take this opportunity. So he goes to the node managers, and the node manager accepts this piece of data, checks it came from the from authority. So here the from is network addressable element manager. And if it's not, drop it. Takes this piece of data and basically he updates the node account. So the node account, just like the user account, he updates that to say wherever the user is saying you need to have paid me to do this sort of stuff and, you know, give me something so that I store this piece of data. What the network's doing down here when he's updating the node account is saying we're going to reward you, or we're going to recognize you're doing work for us by updating your account. So as a network, we're aware that you're doing a little bit more than you were before we spoke to you. We're adding to your account the fact that you're doing more work. Very important. And then the node manager sends the data. I won't draw on the wall down here. Sends the data to a node, to the node that was selected by the network addressable element manager. The node will then look and say, I'm only going to accept stuff on this network that is told to me by my manager group. My manager group is who controls me, so I need to know that it's them that have said store this piece of data, because it's them that's recording the fact that I've stored it, I want credit for it, and I'm only going to trust them. So the node checks, is the from authority his manager group? And if it's his manager group, then that's perfectly fine. He'll store the piece of data. So it might look kind of complex, but when you break this down, it's actually pretty straightforward. There's just basically a whole bunch of dispatching. We just dispatch as messages come in. So we're kind of saying, if it's a put, my authority is a client manager. The from authority has to be the user, and if that's all true, I'll do the work. If it's a put and I'm a network addressable element manager, the from authority must have been a client manager group, and if that's true, I'll do the work. And same node manager, I'm a node manager, I should have been told by a network addressable element manager to do something, and then I'll do the work. Or if I'm a node, I must have been told from a node manager to do the work. And that gives us this logical network where we can say, we will identify this relationship here. We'll identify the relationship, and based on the type of request that's coming in, we'll do certain things. So the relationship first has to be something that we have defined. There is a relationship from client to network address, and if there wasn't, this message wouldn't go through. So we are defining those relationships, and those definitions of those relationships are really important, because any message that's outside of that definition just gets dropped. And routing, as I say, is already guaranteeing that this authority stuff is correct. So in the Vault network, we're really saying we've got these different types of personas. So how can we introduce something that means that these types of personas will speak to each other, and based on the message type, get, put, post, will execute a piece of code. So if it's a get, it'll do one piece of code, put, it'll do another one, post, it'll do something else. So we're defining these relationships, and then we're defining actions. The actions based on what the request type has been, get, put, or post. So the relationship gets defined, and then the action gets defined. And this action here, so we'll go back to the workhorse. The workhorse here of the whole network is network addressable element manager. So client manager is doing something pretty simple. It's saying, I need to be told from a client. Node managers managing nodes. So there's a relationship where there's a management thing happening here and happening here. But if you look from the node perspective, you're just managed by your close group. From a client perspective, you're managed by your close group. So we can take those out of the picture just now and look at the workhorse, look at the kind of Clydesdale of this whole thing, the network addressable element manager, because it does something that the other types don't do. And it's all to do with this data type identifier. So our network addressable element manager, for us in MaidSafe, because we're doing things in a certain way and we've been thinking of a certain thing, it's data manager. And that's what we think. It's that data manager because that's what sits there and all the rest of it. But it's not the data manager. So what extra step happens in the network here? Now we're just focused on this network addressable element manager. So we get this message and we say, I am network addressable element manager. So the from authority, let's say, could be from different people, different types here. And data type. Let's ignore from authority just now. It's going to confuse. So this message comes in. We've got all the authority checks, doing whatever we were doing previously, and we've got data type. This data type here is important because that's what starts dispatch to the network addressable element manager. Based on a data type, goes through another dispatch. So here, if our data type is immutable data, then we're doing this data manager's job. Really is, so if you look at the code just now, that's your data manager. However, if that data type is structured data or our SDV thing that we were, the structured data versions or the version thing or the transaction thing or whatever, it's a structured data manager at this stage. So we're getting structured data through and we're going to version it or something. Let's just say we're going to handle it different from a data manager. So this particular data type is going to be handled different from the data manager's data types. And that's what this second dispatch is. So it's saying we're coming through the network, we're getting to a level which says this is network addressable element territory. And we get into network addressable element territory. The network addressable element saying, I could be a data manager, I could be a version manager, I could be multiple other things as time goes on. We'll see what those are. But at the moment, it's saying, I've got a couple of things that I can be. And those things that I can be are determined by the type of data that's getting passed through to me. So from the structured data version thing or the transaction manager, whatever we want to call this thing, which seems to be lots of different names, or the data manager, the difference between these two is literally what is the action that we do on that data type? How do we handle it on the network? Do we store it somewhere? Do we store it ourselves in a certain account or a certain container? Whatever it is we do, the data type. So that data type, you could imagine, could be immutable data. It could be structured data. It could be a computation. And so with structured data and immutable data, we can handle all data types in terms of data. But we use different mechanism. It could be computation that the network addressable element manager is going to be handling. But the type of data or type of message, which may be more accurate, allows us to dispatch that call to the correct piece of code. So we've split transaction manager and data manager into two lumps of code and two separate personas. And really, they share the network addressable element manager persona type. So network addressable element manager persona type is something that we specialize. We specialize that network addressable element manager for a data manager or for a transaction manager, which I think we should just be calling structured data manager and unstructured data manager. But anyway, that's a separate issue. It's something we just need to clear up. So the Vault network, when you look at it and stand back, is a really simple network now, because it is these 4 things or whatever it is there. So it's, what am I being asked to do? Who am I when I'm being asked to do it? Who's asking me to do this thing? And what is it I'm being asked to do it on? It's fundamentally what the Vault network comes down to. And this, what am I being asked? Who am I? Will limit who can ask you to do it. And also will limit what they can ask you to do it with, if that makes sense. So really it's just a kind of set of rules, and through these small set of rules here, we can define very simple logic that says, if you're type A and type B asks you to put type Z, do it. But if you're type A and type B asks you to put you type Y, and we've not coded that rule, drop it. So we're saying to the Vault network, specifically, if a message comes to you, and that message will define, as a Vault, it'll define what you're going to do with this message. It'll define who you are and what that message that you've to work with is. Now, the from authority, you might get a message that is allowed to come from 2 different authorities, and depending on what those authorities are, you'll handle them differently. So the bit of code in the vaults, if you like, is just one big dispatch thing, maybe dispatch a couple of times, is basically saying, here's the basic rules. You can get this kind of data from that type of person and handle it. You can get this other type of data from another type of person and handle it. And all that we are doing in that respect is we are coding the handle it. That's all we're doing. We're just, every time that a message goes through the network, depending on where it lands, will make us handle it or not differently from the previous and the next stage. So vaults becomes an extremely simple mechanism in terms of handling data, handling computation, handling safeguard. All these things become really easy because it's all, the premise of vaults is this. It's very simple dispatch. And it's quite hard for us being working in vaults for so long that can be so simple, because that's impossible that it can be that simple. But that's actually what it is, as long as routing's doing its job. So this is the basic premise of vaults. This is what vaults fundamentally is. It's a thing, and unless you code handle this message from this guy, it's not even going to get to the handle it logic. The message will be dropped. So the rules that we put in place are, if you're this and this, then, and so you've got, if the message type is this and you're that and this, do this. And this is all that we're doing. So it's like one big monad function. If you like, you could actually write it in a monad where our handler is basically the closure, because that should be very, that there should be very limited. That handler. So you can imagine the whole vault network, if you like, could be written in a way that you could just say, I'll do it with an if statement. If type equals A and U equal B and from equals C, then, or handle it. So do your stuff. So that's basically what the vaults would be like. So if it's that type and you're this guy and it's from this guy, put in your handle it code here. And we just do a bunch of them, a bunch of these rules. So this is basically your simple rule, and this is how the vaults work. That's all that they work. So we've got certain message types. So we've got get, put, post. We've got certain persona types. So we've got client, client manager, and all the rest of it, and that's the persona types there. And then we just, well, when that happens, what do we do? What's the bit of code do we need to do? Put that in place. So that's the Vault network. That is the Vault network. Now, there's an additional bit of complexity here. So if you imagine that with this, you can do whatever you want. Now, it's almost getting to the stage where it's like a kind of, you can imagine like a kind of Turing complete type network. You could start putting anything in here because we've got conditionals and all the rest of it. So then we've got execution, but that is the Vault network. That's all that there is to the Vault network in terms of how will this thing handle putting data, getting data, putting SafeCoin, alter SafeCoin, you know, anything, putting any kind of data that's mutatable, like a session key or a session. How will it handle all this sort of stuff? Everything can be done with this simple logic. So why? Where's the hard bit of it? Because this is too easy. This is just too easy. So there is some parts that are quite difficult. And this just goes, we just go back to fundamentally, the vaults live in XOR space, so we're not bothered with routing here. But if you take vault A and vault B and put them right beside each other, as close as it can possibly be on the network, they will not hold the same data. So we're saying this guy, he's holding, what do we know already? He's holding some client accounts, some node accounts, and some data type accounts. Just say they're accounts. The closest possible vault to him on the network, his nearest neighbor, which we don't really care about in vaults, but the guy that's very, very close to him will have almost the same account information. Almost. It'll never be the same. It's almost the same. A guy that's far away from him here will have account information which is more dissimilar. And a guy miles and miles away will probably share nothing of this account information with this guy here. So the point being, this is where you've got the decentralized thing. His data and his data will be different. So they might have client 1 has stored 5 megabytes, and he'll have client 1 maybe stored 5 megabytes, and that's good. So they do have that single account, but this guy then will have client 2, 4, 6, and this guy might have client 2, 5, 9. The actual account database that they have will be different, but certain account records will be the same. Or will they? Well, the answer is probably. They'll probably, for that single account, which they both agree that they're managing the account for client 1, they may or may not agree on how much the guy's stored. Just because of the way it's a decentralized network, that here, this guy just got a client put 1 meg, and this guy, the put is on its way to him. When we ask them, how much is this guy stored, he sees 5, and this guy here sees 4, because this one's just not reached him yet. Just a matter of timing. And that happens throughout the network. So they do share the same account, but they don't necessarily agree at this moment in time on how much that guy's stored. So we need to handle that somehow. That basically they're going to hold a different set of records from each other, and the individual records that they do hold may not quite agree with each other. And that actually is solved. That took months and months and months and months and months of head banging previously, because we had, I think we had 3 different mechanisms with sort of caching, with synchronization and various other things happening. What happens here is there's a group of these guys. As we know, there's groups, and routing handles all that stuff. And when there's a churn event, routing says something's changed in the network, throw out all your data, all your accounts, just throw them all out. And say there's this group of 4, and he's seen 5 meg, he's seen 4 meg, he's seen 5 meg, and he's seen 5 meg for this piece of data that was in flight. What routing does, when we send that piece of data, so as client 1, routing will send back to the group near client 1. And routing calculates what that group is. We don't know, we're vaults, we do as we're told by routing basically. Routing says this is who you are, and that's fine, that's who we are. So that information comes out. So a 5, a 4, a 5, a 5. And when it comes back through, inside routing, we've already told routing through the interface method in vaults how we would like to merge this stuff. And that's probably changing a little bit, but what we do is we take the median value, so we're going to get 5 here. So when this message comes back, we're not going to get from routing 5, 4, 5, 5. We're going to get from routing a single message, client 1, 5 megabytes. And that's a account type. So that's going to come back, client 1, 5 megabytes. You think, whoa, is that always going to be right? So you think, well, okay, let's change it. Let's go 4, 4, 4. If that happened, that's going to come back, client 1, 4 megabytes. Now, You might think, well, if that's 4, that's wrong, because this guy here's seen an extra message somewhere. But once these guys get the information back, this message eventually lands. They're going to go up to 5 anyway. The next time there's a churn, they're going to get back here 5 megabytes. So the account information that each of the nodes have may be slightly different, but we can cope with it. The thing is, we can cope with it. So for all of the account info, you're holding accounts. Every account you've got the name of the account. Defines where it lives on the network. So account ABC is going to live close to the group ABC. DEF, well, close to group DF. The type of account defines what persona is responsible for it. So it'll be a client account, node account, or data. Let's call it immutable data account, which would be for our data manager. And for structured data, we could treat that the same, but that would be for the structured data manager. We can treat that just as account information, which is a really kind of nice, interesting way to do it. So the account, the name of the account will tell Routing whether it's coming back to you or not. Because you may have had the account here, a churn event happened which put another guy there, and you won't get the account back to you. It'll come back to these guys. Routing sorts that, so we don't need to worry about it. When we get an account back, so Routing will have used that name to give it back to us. We will dispatch on the type of account, which tells each persona, data manager, client manager, node manager, here's your account information back for your account type. So client account type, node account type, data account type. That gives you your data back. So churn handling is basically saying the database that we have, which is split up amongst all these nodes, and there's all different databases, so different nodes get different parts of each database. The churn handling and routing make sure that the right stuff comes back to us, and we make sure that we give it to the persona that's responsible for it, and the whole network settles. So that's how churn handling works. So the account transfer is all to do with churn. And what Routing's saying is, if you're supposed to handle an account, we're going to give you the account. So we'll give you an account, and you're going to be handling it. So how you handle it is going to be up to what persona you give that account to. And with that taken into consideration, so you've got the initial part of vaults, which is the type, who you are from, and then the data type. So request type, who you are, where it came from, and the data type. So that's the easier part of vaults. So one other thing, just to finalize this, so we kind of did, when we were doing the type thing, we kind of did a put, because it's about the hardest you can do, the most difficult thing you can do on the network from a client perspective. If you're a client and you're doing a GET, you just go straight to network addressable element managers. If you're doing a GET. If you're doing a put, you have to go through a few jumps. The network goes through a few jumps to do that put. If you're doing a post, so here you're reading, here you're creating something here. And with post, you could just be mutating something here. Mutating something is actually pretty easy, because you go to the network addressable element manager, just like you do with a GET. But the thing is, what you're saying here is change or edit something I own, i.e. I have signed. I put something I can prove I own. And an example of that would be you put a session. So you put a session piece of data, which is basically structured data thing. And that session will have an identifier of some description. It could be a digital key, and it could just be the name of it. So it'll say, I'm session ABC. So user ABC can change me only user ABC. So if a group came to try and change that, the network would say, well, you're a group, what are you doing? We need user ABC to change it. So user ABC signs change request to change that piece of data. And that's why in our trait for the data, we can return the owner. So in routing would say, this message here doesn't care, but it would say, this message here has been signed, just like every other message has been signed. And I'll ask the data, can you give me your owner? And if the data's got an owner, routing confirms that the message is signed by the owner of the data when it's coming from the client. If it's signed by the owner of the data, routing will give the message up. And this session can be altered, because when Vaults gets the alteration, for session data type, it's signed by the owner of that session data type, then we're okay. So this post here, mutate something you own, or you can prove that you own it. Put, create something which doesn't exist at the moment. Now for us, we can get to network addressable element managers and find out it already exists in the network, but as far as the user's concerned, he created that. He doesn't need to know or be concerned with it already existed. That's to do with the network itself. And get, just read something from the network. That's all we're doing, read. Just go to network addressable element and get the thing back. Go to network addressable element manager and alter the thing. Or go to your manager group, your client managers, and request that the network do something for you to create this piece of data. And that's 12:07. I'm 7 minutes over, but that is the Vault network. And
We got 5 minutes left, David. We only started at so we still have 5 minutes if you wanted to say something.
Cool. Well, no, I think I think that's fine. I think just this overview is enough to let Spandan and Fraser come back and say, well, here's a bunch of questions now. How do we sort this stuff out?
Excellent. What do you guys think?
The main thing is it's simple. Don't make it hard. It's simple. It's not simple. It's not hugely difficult. How's about that?
Right, I'm gonna stop the recording 1 sec.